So guys, if you just came in, we're going to do an example of a related rates problem, because I didn't put one on the practice test. So 20, oh, ooh. So this guy?
Yeah.
Okay. I'm pretty sure we talked about this guy before, but, and there are...
Is this the one with, that one, trig thing?
Well, you could either...
Law of cosines?
No. We could do that one if you want to instead. Let me see how I can do this best. Ooh, shit, I didn't want to do that. Let's see what this does. Oh, there we go, it's back there. It's not very useful. Where's that one? That's over there. That one's right there, okay, sure.
Up there.
So you got book and you got stuff, okay. We kind of looked at this one before, and I did it a certain way, and I told you at the time that you could find right triangles if you wanted to. The whole problem with this one is it's not quite similar triangles because there aren't triangles inherently in it, but you could find them. So I kind of did it the way that came to me at the moment, which I still like better, to be honest, but you know, I'm the weird guy in the room, so just because I like it doesn't mean it's a great way to do it. It's 10 meters long. You don't have to draw 3D, right? All that matters is that you get the isosceles trapezoid, 30 centimeters at the bottom, 80 at the top. And the height is 50. And if I draw that in like that, you can see I've created a right triangle there. If you want to use it. Can you do it, Jeff? I don't know. This is Epsom. So if I do this, yeah. Multi-lifted media. Okay. So this is number 27. We kind of looked at it before. I'm almost certain when we looked at it together, I got you to the point where we identified the relationship, but I did it by creating a linear equation. So let's just figure out what drives me to realize what I need to relate. So I'm filling this thing with water, yes? Or water. Go ahead and say it. H2O, high quality. So just pick a place for the water to be. So what variables do I need? What's changing over time?
Height.
Height, so I need an H for the height. I need a width for the water's width. Those are the things that are changing over time. And I understand this goes 10 meters back. We're just looking right at the face of it. You don't have to draw 3D for this. Let me see. Yeah. The other thing about this problem was it's 10 meters long and then it's got centimeters everywhere else. So let's go ahead and change that. How do you change 80 centimeters to meters? Real quick.
Is it like 1,000?
Very quick. My fellow Americans.
Oh, don't you like
Most
move
of
the
us.
decimal twice or something?
Yes. So real quick. Everybody knows kilometers, yes?
Sort of, yeah.
No. Have you ever heard of kilometers?
Yes.
That's all I mean. I don't mean go out and walk a kilometer for me right now. Not quite, try again. You have to call me. Did I do it? No, try again. No. Everybody's heard of kilometers. There's something here, and there's something here, and then there's meters. Because kilo means what? Where's all my people watching crime shows? You got a kilo of cocaine is 1,000 grams of cocaine, right? Kilo, okay. And then you got, everybody knows centimeters for sure, but not everybody knows decimeters. Everybody knows millimeters. I've given myself no room here. Not many people know hectometers, and not many people know decameters. Alright, this is all on the side now, I'm sorry, I'm taking way too much time for this shit, but the way metric works, if I have 2.7 kilometers and I wanna change it to decameters, look, 1, 2, 1, 2, 270. Because metric is based on 10 and our number system is based on 10. So, to convert from centimeters to meters, I go back 2 places. Just because I go 1, 2. King Henry died Monday drinking chocolate milk. That's a little mnemonic device to remember. Kilometers, hectometers, decameters. King Henry died Monday drinking chocolate milk. How important is that for us in this class?
None.
Right now, not. How good is this to know just in general? It's freaking good because every other country on the face of the earth uses this shit, so, you know. I'm never gonna leave home. Okay, fine. So then 1, 2, this is 0.8 centimeters. 1, 2, this is 0.3 centimeters. 1, 2, this is 0.5, I'm sorry. Meters. Okay, so now all my units match. Okay. So, if the trough is being filled with water at the rate of 0.2 cubic meters per minute, bam, stop. What symbol do I use for that information?
DHDT?
The water
Oh, no,
is being filled with
DRDT.
water at the rate of 0.2 cubic meters per minute.
Volume?
Change in volume. As you pour water in, what's changing? The volume of the water is changing, correct? Other things are too, but the units give it away. Where do you go? 0.2 cubic meters per minute. How fast is the water level rising when the water is 30 centimeters deep? Okay, so what symbols do I use for how fast is the water level rising? DHT. So that's what I'm looking for. And then they give me a snapshot of 0.3 meters for the height, yes? Okay, stop for a minute. Everything I've written and drawn is just capturing what the problem tells me. I haven't actually done much work yet besides moving a decimal. Maybe. What is the formula for the volume of this thing? If I chop this trough anywhere along its length, what does the cross section look like? It looks like a trapezoid. Therefore, it's a repeated trapezoid. So it's the area of the trapezoid times 10. How do you find the volume of a repeated shape? The area of the shape times how often it's repeated times the length of the height. Okay. What's the area of a trapezoid?
1/2 the base plus basically 1 of those bases.
1/2, the sum of the bases. Now be careful, we're talking about the water here, yes? Water. So one base is 0.3, the other base is?
0.8.
No, that's
no,
the trough.
0.5.
I'm talking about the water.
0.5.
No, I'm talking
W.
about the water.
H. Wait.
Oh, W.
W, thank you. Base. Times the height, right? So what's a triangle? Half base height. What's a trapezoid? Height, listen, try it. Half, sum of the bases times height. It's a decapitated triangle, so it might as well kind of look like a triangle formula. You guys can think of it as a decapitated triangle now. There could be only one. Okay. So what's wrong with this?
2 variables.
Too many variables. So then this is what tells me, this is what motivates me to say I've got to find a relationship between H and W. And one way you could do it, and I'm just not going to do it, I don't like it, I think it sucks. You could find the right triangles, and you could work with them. Don't know why you would want to. Alright, so this little right triangle, so see how this is similar, but then don't you have to know how long that is, and of course you could figure it out, it's not that crazy terrible, but it just, to me it just sucks. Let me stop for a minute. Any damn time we do a problem, that problem doesn't mean shit, because I am not going to give you this problem. What matters is what made me do what I did, right? So a lot of these problems I've been worked out for a long time, so when you ask me about them, I'm kind of working it out for the first time. So I want you to know what it is that's making me do what I do. I didn't practice this damn problem. That would suck, because I want you to see me go through the motions. Okay, what do they tell me? What do I do? Okay. So then the volume would be all this business times 10. Is that cool? half of 10 is 5, so I'm just gonna do this. 0.3. So now if I just find a relationship between W and H, and this is where I did a, what did I do? I kind of made like a linear relationship, and like I said, you could do the right triangle if you want. Real quick, how long would this side be? Because it's an isosceles, meaning it's the same length on both sides. Yeah, if this is 0.3 and this is 0.8, this would be, if I chop that off, there's 0.3 in the middle, there's 0.5 on the outside, it's supposed to be 0.25 on each side. And then you can use similar triangles there. Because all you gotta do now is, if you figure out relationship between H and W, you solve for one of the letters, plug it in, take derivatives. Which letter do you want to get rid of?
W.
W, because it doesn't ask me about W, it doesn't tell me about W. So screw W. It gives me the height and it asks me about the height. So I want to get rid of W. How's that? Is that enough to keep going? I want to leave you something. Okay.
Would we figure out the W from the volume?
Say again.
To figure out, I'm sorry, to get rid of W?
You have to get a relationship between H and W. And the way I did it was, I just found an equation for this line. So when the height is 0, the width is 0.3. When the height is 0.5, the width is 0.8. Do you guys all agree with that? At the base, it's 0.3. At the top, 0.5 meters up, it's 0.8. I can make a line equation that would relate H and W. I'm golden. That's what I did. That makes more sense to me. Okay. I don't want to spend all day on the specific problem because it says very specific things.
Can you give us one that you actually would give us?
I could give you this one. I could. You know I'm not going to, but I could give you a trough with a different shape. Like a triangle, which would be more direct, which is, I think, like one we did before. All right. What was it? Somebody else had a different one, I thought? No? So it was, did anyone have another one in here that tripped you up that you want to look at? Or I could just pick one, either one. What about, where'd it go? Or that's that one that you're talking about. We sort of set that one up together. There's the conical pile of stuff. There's kind of a, this is a little more straightforward. This is a swimming pool problem, sort of like the trough problem. It's up to you guys. Jay, do you want the answer key before you go?
Yes, I would love that.
Okay. And there's one little mistake on there that we're gonna talk about.
Thank you so much.
Sure. Let's see. I think we talked about that one, for example. We talked about the baseball diamond one for sure.
Maybe do one with like a shadow.
There's only, it's not like a category of problem, the shadow kind of problem, but I forget which one that was. Here, 15? I mean, the thing about 15, the thing that gets people down about 15 is the fact that the shadow moves because the guy is moving and because it's growing because of the angle it makes with the light. So there's two things that's making the shadow move. So you have to add both of those together. Kind of like if I'm on a train, I'm standing still, I'm going like 20 miles an hour. If I start to walk, I'm going a little faster now, or slower, so I've gotta combine the two together, if they're working together to move me. Me plus train, yes. You wanna look at this one again? I can't remember how far we made it with this one. You wanna look at this one again? It's up to you guys.
Yeah.
Sorry, somebody was like, so very quickly, we made it to a certain point here. There's this guy, here he is. Very strangely shaped. Don't give him shit about us. Fine. No shame. 15-foot tall pole. There's the light. Here's the shadow. Shadow is here. I'm gonna call this X. Where'd he go? Man 6 foot tall, so this guy is 6 feet tall. Okay, and then this I'm gonna call W for walking. I didn't want to call shadow S because then it looks like a 5 for me. So you can use whatever variables you want to, it doesn't matter. Can somebody tell me what symbols I should use for 5 feet per second? Careful.
HTT?
Careful. DWDT. That's why I called it W, because that's him walking, yes. That's him walking. DWDT is 5 feet per second. And then the question they're asking is how fast the tip of the shadow is moving. And that, when I did it with some people, I could have been a little more precise. DXDT is just a part of that question. Here's the tip of the shadow. What is it comprised of? How far away is that from the lamp?
X plus W.
W plus X, I like it. So then the shadow is really this. This is really the question. How much is that length changing, yes? Because it doesn't say how fast is the shadow growing, that would be DXDT. It said how fast is the tip of the shadow moving. Holy shit, you guys kind of with me? And again, this is a good example of if you did everything right except you solved for DXDT and you didn't realize the little nuance there, I'm not going to take a ton of points off. Maybe like an ounce of points. You guys sit back with me. You just got to show me that you understand the process. If you miss some little nuance or you make a little mistake and forget to change units, that's not a big deal. It's if you have no idea how to set anything up, that's a big deal. So don't I already know what DWDT is? So I'm gonna focus on DXDT, right? So let me ask you, this one's very in your face. This is a problem. If I gave it to you, I need you to be like, thank the gods, because what's going on in this problem? What's the geometrical idea that's gonna set up a formula for me?
Big triangle, small.
Yeah. Similar triangles. So there's a million different ways you can do it. Maybe not a million, but there's several different ways you can do it. And depending on how I feel at the moment. So I could do this, for example. I could say big triangle to small equals big triangle. You can do it, Jeff. To small. Right? If that's not the way you would have set it up, I don't care. We would end up in the same place. You could do 15 to W plus X equals 6 to X. Like big to big, small to small, it'll still come out the same way, because what am I going to do now? Cross multiply. So all the other ways you could set it up just involve moving those things. They would still multiply to be the same thing. So then I get 15x equals 6x plus 6w. So I get 9x equals 6w. Yeah, so then I get, it doesn't matter. I get 3x equals 2w, so then I can take derivatives.
You just take the derivative from here.
Yeah. The most evil part of this problem. Does anyone know what the most evil part of this problem is? You're all like, the fact that it exists. Huh? No, because that's the normal part of these problems. What do I do now? What do I do now? Let's see if you guys, what do I do now? So, it doesn't matter where shit. It doesn't. Because what do I do now? What am I trying to solve for? I want to know what dx dt is, yes? So what do I do? Take a derivative. 3 dx dt equals 2 dw dt. Do you know what dw dt is? And then you can divide by 3. So you could have solved for x, but it doesn't matter. Because when I take the derivative, it's just going to come to the right anyway. Who cares? So now you just plug shit in, yes? So most evil part of this problem is, did I care about 40? That's what you call a red herring. Like communists. Is that a red herring? You got it. Alright. Is that alright? No? So, when you get dx dt, what was dw dt? 5. When you get dx dt, that's not the answer. What's the answer? Yeah, add that shit together, yes? Yes. You already know one of them, you're just figuring out the other one. Evan, can you close that door for me, man? Thanks. Just so those wandering groups of people. I don't want to hear that, yeah, that's Mr. Moore. Yeah. That sucks. Yes? Yeah.
So you're saying find dx over dt. You already know dw over dt. So it's just add them together.
Because
That's our answer.
what tells me how quickly this is moving? How quickly this is moving plus how quickly this is moving. Yeah. And we already know dw dt, so if I could just get dx dt, I add them together. I like it. Now, the thing that you guys, I understand you hate this, and this, I understand. There's no streetlight shadow category of problem. You can't memorize it. You can't memorize much of this. Now, what is always the same? Draw the picture. What are variables? What's the formula relating them? That's basically always the same in every single one of these damn problems, right? Once you get those, are there too many variables? Did they tell me something else? Can I relate those variables? You with me? I think the baseball diamond problem was a good one for the fact that I didn't have too many variables. The minute I set up my equation, I could just take its derivative. So that can happen. You don't always have to get a relationship if you don't need to.
When you have your formula, do you need to take the derivative first, or like solve in terms of one of the variables first in order to, you know what I'm saying? Like when you have to.
Well, like this one, I kind of wanted to do this on purpose. I didn't solve for any variable, but I had simplified it as much as I wanted to, so I can take its derivative. I could have taken the derivative right here. I could have, and then I would have combined things later. But I want to simplify as much as I can. Does that? Yes.
And for units, how would you figure out how to
Well, I mean, what are the units used in the problem? Feet per second. Yeah, and that's the only units in the problem, correct? Yes. So I know that's going to be the units at the end for me. Okay. Because again, when I take this derivative, what is it? This is feet, that's seconds. So it's feet per second. Everything's feet per second. Okay. So I need you, you're in calculus. Like, what? This is where you start to leave behind everything is strictly in a certain category. What you're starting to realize is there is a process that doesn't change much. The picture I draw, the relationships I have to find, all that shit can change, but the process does not change. Identify your variables, set up your equation, take a derivative, plug shit in. That's the general kind of outline. Each one of those has a decent little amount of work, so that kind of makes it sound easier than it is. I understand that, but draw the picture, identify what's changing over time, give it a variable name, set up a relationship, an equation, take its derivative, plug shit in. I know it's harder than that, but that's the outline. That doesn't change. Each problem has its own thing. Yes? And that's just the reality. It's the way it is. So you do have to stop and think and draw and think and hope, try. Bless you. Okay, moving on. You can ask questions from the practice test, from the whatever.
Can we do a 4.1 over 50?
That one specifically I won't do. No, I'm joking. 15. Oh yeah, good. Okay. What shows up right before the number 49 in the problem section? Yeah, so when you see that little graph, it means do this shit in the graphic calculator. Now, something a lot of people didn't realize. What did they give me in number 50 and 49, but we have to do 50. They give me the derivative. And they ask me how many critical numbers does f have? In general, how do I find the critical numbers for a function? Take its derivative, set it equal to 0, correct? What does set it equal to 0 mean graphically? No. Yes. If I want to set a function equal to 0, and I know what you're talking about, but I'm one level beyond that. If I want to find where a function is 0, I just see where it hits the x-axis. So this just says graphically. Just graph the damn thing. And just see how many times does it hit the x-axis. At some point, it's going to not go up enough to hit it anymore. So you can just count. You can just literally, because I don't care. It doesn't ask you what they are. It just says how many. You guys see that? So if you graph that, and then just see how many times it hits the x-axis. You guys with me? Huh? I'll tell you this is not. This won't be infinite, but you're right. It could be in general, but this won't be. And let me see if you guys are cool with this. If I have sine x, how far up and down is it? Negative 1 to 1, correct? What if I have sine squared x? Can't be what? Can't be negative, so it goes from 0 to 1. You guys with me? What if I have 5 sine squared x? Now it goes from 0 to 5. Crazy. Cosine squared x. Do you see it? What's in front of it? Don't say 100, because that's not right. What's in front of cosine squared x? 100 over 10 plus x squared. Let me say this again. I'm not going to say that, because then I can see. Can't I pull the cosine squared over? Isn't the 100 over 10 plus x squared, isn't that in front of cosine squared? I need you to really get this. Anything that's in front of the cosine is an amplitude, correct? You guys remember this? What is happening to 100 over 10 plus x squared as x gets big? 100 divided by 10 plus x squared. As x gets big, that is getting really small. So that's why I did this. The amplitude is getting tinier and tinier, and since it's -1, eventually it's going to get to the point where it doesn't go across the x-axis anymore. It's not going up high enough. So that's why there's only be a finite number of critical numbers. You guys with me? Somewhere between 10 and 20. Just to give you a little more help. Because you got to make sure you get a look far enough out. Yes. So graph it and then just stare at it. And then count. Yeah. Is that all right? I agree. This is a weird problem because a lot of you guys are so used to the first thing you do is take a derivative. They already did it for you. Thank the gods. I feel bad for those of you that took another derivative and like, oh shit, no, don't do that. Yeah.
What if like we weren't able to like graph it or calculate it? We set that over there for the
Yeah. I need you to see if you try to do that, can anybody see how insane that's gonna be? Can you get x by itself? Don't you have to take inverse cosine? And if you do that, the other x is stuck inside of inverse cosine. So then you gotta take cosine, and then the other x is stuck. Whack-a-mole, whack-a-mole. You can't solve it for x, so don't try. Unless you've already tried, then stop. I appreciate it. I appreciate it. Oh, okay, Tom. All right. I appreciate it. I appreciate it. But don't do that to yourself. Okay. Yes.
So you're saying the cheat code is basically graph it and you see how many times it crosses the x-axis?
Yes, and I really want to know. I really want you to understand why. Let's go through it. To find critical numbers, I take a derivative. They already did. I either see whether it's undefined. Why is this never undefined? Why is this never undefined?
The denominator is never going to
The denominator is always at least 10. Good. Because it only goes up from 10. 10 plus a positive number or 0. No undefined critical number. So the only critical numbers could be where that thing is 0. So then I graph it and see where the hell it's 0. And what does it mean to be at 0 to cross through the x-axis? I need you to understand that chain of reasoning. You have to kind of take the problem as it's given to you and translate it into this is what you want to do. Because they're not going to say, graph it and look at it and see how many times. No, you got to go, oh shit, that's what that means. And the first level is just, you know how to find critical numbers. They've already done the derivatives, and I just got to see where it's 0. Oh, graphically, that's x-axis. How many times? Okay, bam. Okay, maybe. Good question. Because that'll trip you up. It's wide open. If nobody's asking anything, it's completely your floor. Tyler.
Can we use 37?
4-1. I don't know. Let's see. More about what. Plus, that's my home state. That's my home state, and it's messing with me about water. Born in Savannah. All right. So the water level of Lake Lanier in Georgia during 2012. All right, this one is funny because can you guys tell me what's the hardest part? Mercedes, are you leaving? Come here. Everybody's had enough of me, I understand. There you go. Okay. What is the hardest part of a problem in 3947? What's the hardest part? No. What is the hardest part of that kind of problem? Setting up the equation, yes? Yeah, they gave it to me. They did it already. So that's the water level. Estimate when the water level was highest. How do I find the highest point on that graph? There's no graphing symbol, by the way. I didn't want to say it like that. It's tricky. You don't graph this thing. No. How do I find the highest point on a function?
First derivative test.
Take a derivative. Yeah, first derivative test. Yes. Take a derivative and set it equal to 0, or where it's undefined, but this is polynomial, so it's not going to be undefined. You guys? Yes. So, dear God, when you see me say something like, here's a profit function, what was the highest profit? Derivative, equals 0. Yes? That's got to be an automatic. So like if I said find the slope between these points, you go, y2 minus y1. That's an automatic. You know exactly. Okay, so just take this guy's derivative. There's a lot of ugly decimals. Who gives a shit? Because you guys have calculators. When you take a derivative, what kind of function are you going to be left with? Yeah, squares, quadratics. Probably one you're not going to want to try to factor. So what are you going to be using? Yes. Because the job of quadratic formula is to find when a quadratic equation squared is equal to 0. Maybe. Once you get the critical numbers, you've got to check to make sure that's actually a maximum. Yeah, like Ruby said. Yes?
Can an undefined point be a maximum?
Hell yeah. Can somebody draw in the air or use your hand somehow to show me? That's good. I'm opening myself up to lots. How you can have an undefined point that's a point where the derivative is undefined, but it's a maximum. There we go. Dave's got it. You got it. Yeah. Right? That's a little extreme because it looks like. So this is definitely a maximum point on my little Christmas tree here. Yes. But the derivative is undefined. So that's why critical numbers, they have to be a complete list of where maxes and mins could possibly happen. And they could happen at a point where the derivative is undefined. You still don't like that, but I don't know what to do for you. But.
Is that only when, like, there's discontinuity in the function. right?
Well, discontinuity of the function kind of like, it eliminates that as a possibility. So this is not a discontinuity in the function, this is a discontinuity in the derivative. This is a disturbance in the force. Yes. That problem on the test, on the practice test, that looks like this, yes?
Mm-hmm.
That's part B of that one. It ends up looking like this. Oh, Jesus. Just go with me. So that is definitely a minimum, yes? But that derivative is definitely undefined there. It's discontinuous, so it's not differentiable zero, but that is a location of a minimum. All day, every day. That's why when we make a sign diagram, I put a little u if it's undefined, but if it's like, if it's this, what is that the location of? Minimum. Yeah. Doesn't matter that it's undefined there. It goes down to it, comes up from it. Okay. Unless it's an infinite discontinuity, but it's got to be a continuous function through that point. Then that's going to be a minimum. Oh, that. Okay.
That was my question.
Oh, yeah.
It was insane.
Yeah, it's got to be continuous. The function's got to be continuous. Like I said earlier, if the function's discontinuous, that's out of the running already. Yeah.
So after we set the derivative of 77 equals to 0,
Yeah. And you're gonna have to use quadratic form. Quadratic form. Or I don't know if it's factorable. If it's factorable, then factor. But I feel like it's not gonna be factorable. Could be wrong. Huh? Do it. Oh man, you have a much higher chance of doing this than the other thing. Yeah. Huh? In the same section?
Yeah.
What section is this? 4-1? Okay. Oh yeah. Okay, this one. Okay. All right. I love you guys so much. I would say roughly 3/4 of the time, a problem that's at the end is hard because it's conceptual and it's not going to have a lot of work. This is that kind of problem. There should not be a lot of work. There should be very little work. Very little work. What am I on mapping going to do with this function? Yes, because it's asking about max and min, yes? What's the derivative of this function? 1 over 1 donation. Yeah.
Plus one.
Yes, okay. If I plug something in there for x, and we're only using real numbers, what must be true about the result I get from this piece? Must be positive. Is everybody with me? What must be true? Positive. Yes? I want everybody with me. I don't care what x you put, what real number you put in here for x, that's going to come out positive to the freaking 50th power, yes? If I put 0 in, it's 0, correct? So the smallest, these two terms could be a 0. So what is the smallest this could be? Where are critical numbers? Where could a max or min occur?
Wait, how do you count x is greater than or equal to 1?
Okay, let's try this again. If I put any real number in for x, can it ever come out negative? That term. You agree with me? Then no. Same reasoning here, correct? So what is the smallest this term could be? 0. What's the smallest this term could be? 0. So what's the smallest this can be? 1.
All of this plus
Because it's plus 1 if it is. Is this function ever undefined? Is this derivative ever undefined? Where's the only other place a critical number, therefore a max or min could occur? Where this function is 0. What did we just say? It's always at least 1. Can it ever equal 0? It's got no critical numbers. Done. This problem is very quick. I really understand. I saw a lot of people doing all kinds of weird shit, and you forgot that it was 150th power. That makes some shit. Do you do quadratic formula? What's quadratic formula again? X
Negative
equals negative b, and that's all I care about. So that is if it's x squared x number. This is x to the 100th. So this would be x to the 50th. If you do this shit, that's negative. 50th root. Can you take the 50th root of a negative number and stay real? No. So that verifies that there's nowhere. There's just a lot longer way to get there. Some of you guys did the work and didn't realize you should have put a 50th power there. So you thought you got answers, but you didn't. Again, how important is this problem specifically? Not. What's most important about this problem is the ideas behind it. How do I find a max or a min? How does that relate to this problem? That's basically, there are fundamental ideas. How do those relate to the problem I've been given? That's the continuous thing you're doing as a student, yeah.
So just to be clear, that function doesn't have a max or a min, because when you take the derivative, it can never equal 0.
Beautiful. And obviously it's never undefined, it's because it's a nice polynomial, yeah.
Okay.
So if I were you, I'd say, what the shit does that thing look like then? But it's simple. What's x cubed look like? Does it have a max or a min? Okay. So it's not that hard to imagine a function that doesn't have a max or a min. Yeah, and ours is an odd power, so it's going to be some kind of a cubish. Now, cubish with some extra terms could look like that, and they could have a max and a min, but somehow this doesn't have the little wobbles in the middle, yeah? Okay, enough of it. Yes?
Do you problem 9 from 4.2?
Or two?
Would it not have the wobbles because it's an odd function?
No, I mean, again, x cubed, you can have, the most general x cubed looks like this, yes?
Yeah.
It's got wobbles in it. Wibble wobbles, sure. Sorry, which one again?
9 from 4.2.
So 4.2 is all about the mean value theorem.
That's what I was gonna ask, because some of the questions ask about rules.
Oh yeah, so again, mean value theorem says that if I have a continuous and differentiable function, then at least one location between A and B, there's gotta be a location, at least one, where the slope of the tangent line is parallel to the slope straight through. That's mean value theorem. If you just turn your head and make this line flat, that's Rolle's theorem. Rolle's theorem just says the derivative is 0, because in that, so if I do mean value theorem, but my outputs happen to be the same, then the straight across is flat. So then I can just say there's got to be at least one place where this tangent line has a slope of 0. Rolle's theorem is a specific instance of mean value theorem. Mean value theorem just says whatever the shit this slope is, there's got to be at least one place where the slope is the same as that. That's what mean value theorem says. What if the slope is 0? Oh, it's just, mean value theorem is like, you can give it to Rolle, sure. Because he came up with it on his own. So mean value theorem is like, yeah, good job, we'll call it after you, good job, but you're just a subset of me. You guys kind of give them
Same thing, just rotate it.
Yeah, just turn your head a little bit. And so Rolle's theorem is just if this was flat. That's all Rolle's theorem is. So Rolle's theorem has 3 conditions. The function's got to be continuous, differentiable, and the outputs have to be the same. Mean value theorem is like, I don't care, it could be whatever the hell they want it to be. Yeah? Is that alright? Is that the main thing you want to ask about that, or?
So you could just basically use the mean value theorem for different
Totally.
It just doesn't matter.
Because they're the same thing.
Okay.
So, let's verify. You ready? Let's verify this. In order for this to be Rolle's theorem, what must be true about f of 3 and f of negative 1? They have to be equal to each other. Right? Does it change the mean value theorem process if that happens? No. It doesn't change the process worth shit. It doesn't change it at all. I just happen to have, I want to make my derivative 0 now, instead of 1 or 2/3 or whatever. I need this to make sense. So, in mean value theorem, I find the slope between the 2 points the old way. You earn it. No, you do some algebra, yes? You do y2 minus y1 over x2 minus x1, yes? Then you set that equal to the freaking derivative at some point c. So you're finding the derivative calculus way, and you're finding the derivative algebra way, and you're setting them equal to each other because they represent the same damn thing. Just for Rolle's theorem, this happens to come out to be 0. Mean value thing doesn't give a shit. It's like, all right, then just make your freaking f prime c equals 0 then. So what could this come out to be in general? It could come out to be 1/2. It could come out to be 7. It could come out to be -30. It could come out to be 0. So I kind of hate that we gave it its own name, because as a student you're like, okay, there's a different. No, it's the same stupid thing. Change over change. Okay. Sort of like, I don't know why I want to do this, but I do. What's that?
Cosines?
So if you ignore that piece, that's the Pythagorean theorem. The Pythagorean theorem is just a subset of a larger idea. If you happen to have a right triangle, it's this. Why? Because if you have a right triangle, cosine of 90 is 1. So sorry, 0. Cosine 90 is 0. So that piece would go away and it just becomes this, yes? Okay, anyway, I'm sorry. I went a little too far. That's another beautiful example of a more general idea that we normally only know that much of. Yeah, so Rolle's theorem and mean value theorem are sort of the same idea. They're both the same stupid big idea, just one of them reduces to a, 0 in this case. Okay. Yes?
What's the difference between when the questions ask, show that the function satisfy the hypothesis and the conclusion of the theorems?
Oh! So the hypotheses are that the function's got to be continuous, differentiable. So if you have a polynomial, you just have to say it's a freaking polynomial. In fact, I wanted somebody to say that. I'll give you a little cheer. It's a freaking polynomial. Those are continuous differentiable by definition. For Rolle's theorem, it's going to have the same value, f of b equals f of a. Right, so that's showing that the hypotheses are met. Those 3 things have to be true, or else Rolle's theorem doesn't have to work. The conclusion says there must be at least one location C between A and B where this equals, in this case, 0 for Rolle's theorem, right? You with me? So then, I need you, does it say you have to show that it satisfies the conclusion? It just says find the numbers that do.
Yeah.
And if you set f prime of c equal to 0, you are finding the c's that do. Okay, does that make sense? It's a good question, but just do the work and you find that you're finding, because what is the conclusion? There's at least one location C where the derivative equals 0. That's the conclusion. So when you find C, you've done what it's asked. You don't have to kind of like further verify. But it makes sense. Before I use the theorem, I got to show, hey, this meets the conditions for the theorem to work. If I don't show that, it might not work. Six B? Oh yeah. This one is not as bad as I could have made it. And you're all like, it's true all the time, Jeff. What is it that you want to use here? Yeah, I want to use L'Hopital's. I am going to show you one little shortcut that we made a big deal out of before, but now I'm going to let you just realize the truth here. So let me ask you this. You want to use L'Hopital's. Why? What form is this in right now?
Not a form that you could use L'Hopital.
Well, not quite, but is it indeterminate at least? If this is not indeterminate, I can just determine the answer right now. I love that. Yeah, Jeff, you left a lot of shit. All right, I'm sorry. So very quickly, can anybody tell me? In an earlier chapter, I didn't let you just say the limit is x to infinity of x squared minus x is infinity. But at this point, we all see that. Isn't x squared growing faster than x? Isn't x squared going to infinity faster than x? So isn't that going to be infinity? It's like 10 minus 1, 100 minus 2, 1,000 minus 3. They're both growing, but the bigger, the one that's positive is growing faster. So that's going to go to infinity. Are you with me? So what form is this in? Infinity times?
Infinity times infinity, right?
Or what's infinity over? 0?
Ne-
0. E to the negative x squared is 1 over e to the x squared. 1 over big is small. Yeah. Is that indeterminate? Totally, because what's anything times 0? And what's infinity times anything? So what's infinity times 0?
0 infinity.
Everything. Ah! Everything, everywhere, all at once. Okay. Yes.
Can you rewrite it as x squared minus x over e to the
We have to, because like somebody just said earlier, this is indeterminate, but why can't I use hospital dude? It's not a ratio. You got to ratio this thing. So like Cash said, why don't you crazy ass people just do this? Because like we just said a second ago, a negative power makes it flip, so this is what it looks like now, yes? Now what form is it in? Infinity over infinity. So now attack that with L'Hopital's. If I remember correctly, yeah, you gotta do it twice. Every time you use L'Hopital's, you take a second. Is it indeterminate still? If it is, do L'Hopital's. But dear God, cancel some shit if you can. Yes?
Wait, can you tell me what makes it indeterminate?
What makes that indeterminate, anybody?
The fact that it's infinity or infinity.
What's infinity divided by anything? Infinity. What's
Infinity.
anything divided by infinity? 0. So what's infinity divided by infinity? Both 0 and infinity. That's indeterminate. I can't determine the answer. It depends on which one gets there faster. Now, real quick, can you guys just tell me which piece is the top growing faster or the bottom growing faster? Bottom's growing stupid fast. You guys with me? E to the x is already really fast. Squared. Screw that shit. That thing is growing. So I don't give a shit the top is going to infinity because this guy is leaving it way behind. So again, it's like 1 over 10, 2 over a billion, 3 over a billion to the billionth power. The top is growing, correct? But it cannot keep up with the bottom.
Based off what you just said.
It's sort of like your income versus rent. Sorry.
It's approaching 0 based off that.
You could try to write a little paragraph and see if it's enough for me to say yes, or you can just do a little yes. I just want to show you how you can see what the answer is going to be. You know the answer should be 0 because the bottom's growing a shit ton faster. Now just do L'Hopital's rule, and now you know if you don't get 0, you did make a mistake. Yes.
If we do L'Hopital rule and it's still undefined.
Then do it again.
Do it again.
I mean, not undefined. It's got to be indeterminate. Undefined would be determinate. That would be some kind of infinity. It's got to be indeterminate. Is everybody cool with the fact now that undefined is actually relatively cool, especially compared to indeterminate? Undefined is just like 1 over really big, which is freaking 0. Or 1 over 0, which is infinity, yes? So this is indeterminate. So if I do one application of L'Hopital's rule, apply it directly to the problem. Apply directly to the forehead. What's the derivative of the top?
2x minus 1.
What's the derivative of the bottom?
2 e to the x squared.
Yeah, 2x e to the x squared. It's e to the x squared times the derivative of x squared, yes? Can you cancel anything? No. Just to stop you from doing it. Is it still indeterminate? Top is going to, and the bottom's going to. So then what can I use? L'Hopital's, yeah. This is its own problem, and this is its own problem. It doesn't matter it came from L'Hopital's. This could have been the problem I gave you at the beginning, yes? Then you would have said that's indeterminate, let me use L'Hopital's rule. So you just keep using L'Hopital's until it's not indeterminate anymore. And again, if there's ever a time you can cancel some shit, do it. Because then maybe you can make it determinate. So like we did at the beginning when we factored and canceled the problem. That could happen after a couple applications of L'Hopital's. On the practice test, this one, do you have to use L'Hopital's?
Yeah.
No?
No.
Let me ask, could you use L'Hopital's? Do you
You
have
could.
to use L'Hopital's?
No.
Hell no, because what else could you do? Factor the damn thing, because then you can kill the problem, like I just said, right? But, you know, I don't blame you if you use L'Hopital's, right? Some guys are like, I still don't like Hughes, Jeff. Your whole Pulp Fiction shit. I watched that movie, I don't know what you're talking about. Alright, I'm sorry.
Is there like difference in cubes?
Yes, totally. Little dude, big dude, blah, blah, blah. X minus 2 is cancel, then you can plug 2 in.
I'm using L'Hopital's.
Oh, okay. Man, I thought there was somebody on my side. I was like,
I do that shit.
yeah, L'Hopital's is quick, I don't blame you. I might use L'Hopital, I mean, you know, it's quick. Yes?
Look at problem number 13 of the section
4.1. 15?
Sir.
Sketch a graph by hand. Oh, okay. All right, so 15, of course, it says x greater than or equal to -1, right? And of course, what, I mean, tell me anything about that function graphically. Tell me anything about that function graphically.
It's a
Number 15.
line.
Slope of negative.
It's a
two.
line.
Slope is -2, the y-intercept is
Three.
3.
Three.
Okay. Thank God. I was getting very concerned.
X must be greater than or equal
Yeah,
to
so-
1.
Y-intercept is 3.
Mhm.
Yes?
Yep.
The slope is
Two.
down 2 over 1 or up 2 back 1. Down 2 over 1, down 2 over 1, and it's going to continue forever because it says greater equal to 1. -1, sorry. Let's say -1, yes. Is there an absolute minimum?
No.
Is there a local anything?
No.
Because can the local max or min occur at the endpoints? No.
No.
And there's no bumps, so there's no local max or min, there's no absolute min. Is there an absolute max? Yeah. What is it? Oh, shit that, okay, yes. Now, what if I would have changed this to this? What would have happened then?
That would be the absolute min now.
There would have been an open circle here,
Oh.
right?
Yeah.
There would be nothing.
No min.
Because the only thing that could be the absolute max doesn't exist. It's not there. It's not defined. We've seen that before, yes? Okay. Yes.
Okay, so what if you have like the local max, but that's also a circle in there?
Yeah.
Oh, then you don't have a local max. Do you mean like this, but right here? Jeff, stop. There's an open circle right there or something?
Yeah.
Okay, so then I could draw that better. Go ahead, go ahead. Okay, so there's a. What was that? Do you see that? It's like a phantom thing. Oh crap. Can't let that stand. Go away, just go away. Stop. It's gotta be okay, kids. There, now it's just really pronounced. Okay. So is there an absolute max?
No.
Is there a local max? Of course not. Because the only thing that could have been a local max doesn't exist. And I love it. I can't remember if it was in here or somewhere else, but somebody said, what about the point right next to that one? And I'm like, what point is right next to that? What number is right next to 4?
3.99.
Which is 4. 3.9 forever is 4. Anyway, I'm not, sorry. Look it up. It's true. Yeah. How do you tell if two numbers are different? If you take the difference, it's not 0, correct? If you take 4 minus 3.9 forever, the answer is 0.0 forever, which is 0. So 3.9 forever is 4.
So what if you just put 3.9?
Then what about 3.91? So anyway, so that's kind of why you can't get a point. There is no point right next to another point. There isn't. That's the trippy thing about infinity. Yes?
What if there's a like removable discontinuity above it? That make it?
Oh, like if there was a thing here?
Yeah.
No. anytime there's a discontinuity, that kinda like takes it out of the running for these things.
It has no neighbors.
Can't remember if the book actually addressed that or not, but yeah, it's like there's no neighbors to this. And, you know, and you could argue in a neighborhood that that is the highest point, but you can't do a derivative. Well, then you can argue it's an undefined derivative, but it's a discontinuity of the function, which kind of like takes it out of the running for these considerations. So I'm going to give you nothing but that kind of problem. No. I'm really curious if the book addresses that or not. Shrink, there you go. Where are we going next? What you got?
Do we do 24 and 4.2?
I'm going to give you the answer key in a bit. 24, where? 4.2?
Yeah.
All right. Come back to me. So to have one real solution, what must be true? So let me see how else can I say this. Oh, do you need
Yes. What is it?
there's this and this. Yes.
It only touches the x-axis.
Yeah, I have to show that it can only have one location where, for example, cosine x equals negative 2x. There can only be one place where that's true. So what does that kind of keep going? What would that mean cannot happen then? See if you guys. All right, look.
Not following.
If I have a function and it goes through once, what's the only way it could go through again? It's continuous, differentiable function, yes?
Mhm.
What's the only way it could go through again?
If it
the
turn-
function turns. And what does that mean? Or the derivative is positive and the negative is positive. All right. So I'm trying to give you tools to try to start investigating this problem. So consider what that would take. Draw an example with one solution and then go, what would happen for it to be more than one solution? That'll help you figure out what you have to show for this guy.
So would we be finding critical points?
Well, think about what this means. If it goes through once, it can't turn back, which means the slope has to
Not change.
not change. It can't become positive again or negative again, whatever it happens to be. Yes. So,
Can it change and then go back down before it touches you?
oh, if it changes again after that, yeah. So another way to look at this problem is cosine, its derivative is negative sine. Both of those are bounded, yes? Does that make sense? Alright, so now I'm giving you, you have bounded function happening. It's a little bit like that problem where it kind of like got away from it and just didn't cross the x-axis anymore, but not quite. So if you take this guy's derivative, see what you get and think about what that means. And in fact, I mean, I don't want to do it. I want you to do it. Because it's one of these things where the minute you do it, you kind of see where it's going.
It's just a shift in cosine.
Take a derivative. See what happens. Because we've discussed, I try to get you guys to realize it's all about the derivative, just to push you to take the derivative. Take the derivative and start to see what it implies. My God, guys, when you get a problem like this, you gotta play. You gotta play. You're not gonna find example 7.3a is gonna do exactly this. You're not gonna find that shit. You're gonna have to, I just want you to realize it has to do with the slope. The slope's what important. So then what do? You take the derivative just to kind of start investigating. What do I see about the derivative? Does it mean anything? Can I see what it means? Does it, I guess,
Finding the inflection point
maybe not that much.
But on 24, you can't factor out anything.
I didn't say it. There was nothing about factoring any of it. I didn't say anything about
Well,
factoring.
because
any
you
of
have to. You, you have to. You have to find the critical points, don't you?
it. Maybe not. Play with the problem. Play with it. Take the derivative, see what it kind of leads you to. Can you see? Can you see it has one answer?
0.
When x is 0, what do you get? 1. When x is pi, when x is negative pi over 2, what do you get? When x is negative pi over 2, what's cosine of negative pi over 2? 0. And what's twice negative pi over 2? Negative pi. So there's one place where the output's negative pi, and there's another place where the output's 1. What does that mean? Somewhere in the middle it crosses through the x-axis. So somewhere it's got a 0 between the... You just have to show that the damn thing never kind of makes it back to the x-axis. So that's all I'm going to say. You gotta play with the damn thing, right? It's not like when you see this, you do A, B, no. You gotta think about what would that take? What would it take for it to not have another real solution? It can't get back to the x-axis. There's several ways you could do that. If this derivative stays negative forever, then obviously it's never going to get to the x-axis. Or like somebody else said, if it goes up but then turns down and it never gets it back, then that's another way it could never get back to the x-axis. You gotta play with it. I love you guys so much. That's it. You just gotta play with the shit. So a lot of times, I don't know, pre-calculus is the first place you really start to play with shit. For example, proving trigonodities. You guys remember doing that?
Yeah.
That was the first place where an appropriate part of the process was to get it wrong. You pick the wrong identity and it doesn't work, and you go, good, I'm doing this right. Because it's part of the process, is to pick the wrong damn thing. So sure, I could pick something and I could try to use it and it doesn't work. That's part of the process, getting it wrong. And you guys, I don't know. You guys are like, well then you're gonna take less points off if I get it wrong? No, well, you're gonna take some off if you get it wrong, but if you get it wrong, then you try something else. You know, like that doesn't make me feel better, I'm sorry. Okay. So hopefully I gave you enough to just try to play with that thing. Okay. What is this guy's derivative? If I say f of x is 2x plus cosine x, what's the derivative?
2
minus sine x. Right? What is the biggest output for sine? 1. So what it can, I mean, do you see what I'm saying? You guys, can you please get there? What's the most I could be subtracting from 2? 1. So can the derivative of this ever be 0 or negative? Isn't it always positive? Okay. That's all I wanted. If you just take the derivative and think, what does this mean? What is this thing I just did? What does it lead to? What does it mean? So if it hits 0 once, could it ever hit 0 again? Again, what's the only way? If it hits 0 once, it's the only way it could hit 0 again. If the slope changes, but what we just figured out? Slope's always freaking positive. So once it hits, it's like, I want to go back. Oh shit, it can't do it because it has to be a negative slope to get back to the x-axis, yes? Okay. This is the kind of stuff you just have to grapple with. You have to. So anything else I can give you grief about? Huh? No, I mean another problem.
Oh, okay.
I did that problem for you, so that problem's done.
Number 5 on the practice test, is that something we have to do for?
Oh yeah, totally do that by hand.
How?
What do you mean?
Well, first, like, find the slope in between points,
Yes, cool.
and then find where the derivative equals that slope.
Good,
How do you
yes.
solve for that?
Why are you having a juggle? What'd you get to? 3x
Um,
squared minus 4x minus 5 equals 0? What'd you get to?
I took the derivative and I got f prime x equals 6x squared minus 8x.
And the slope you got was 10? Okay.
Nice.
So they set them equal to each other, you get 6x squared minus 8x minus 10 equals 0.
And then you just find
And that's not factorable, so of course what do you use?
Oh, okay.
There you go, cool. Yeah. Now what I would do, quadratic formula sucks the bigger the numbers are, correct? So why not divide everything by 2 before I use quadratic formula? Because the 0 just eats 2 up. So that kind of problem, I need it to be insanely straightforward. What do I get when I take a derivative? I get the slope function. What do I get when I do f of b minus f of a over b minus a? Slope. So all this thing is saying is set those two equal to each other. It's kind of a, now, it specifically is finding locations where that's true, but on one hand it kind of makes sense. I found the slope by calculus, and I found the slope by algebra. And then just setting them equal to each other. That's really the heart of that theorem. Yes?
Can you do 68 and 70 on the 4.4?
Yeah, so this is one, we've kind of seen this idea before. What do you guys think I have to use to investigate this? Yeah, so I'm trying to figure out, let me write it like this, the limit as x goes to 0 of some function, yes? So let me write the function over here by itself. Now if I take natural log of this, what do I get?
Natural log of
What can I do with this when I put that? Now real quick, if I take the limit of this, I'm not gonna get the answer, correct? No. I'm gonna get the limit of the natural log of y, yes? So I want this to make all the sense in the world. If I get the limit of this is 2, that means I found the limit of natural log of y is 2. Then I just raise e to both sides, and then my answer is e squared. I just kill the ln. I just undo the ln that I introduced. I bring it to life, I'm like, thank you for helping, and then I kill it. Yes, again, not a life lesson. Hashtag NALL. So, did I get everything? Yes, I see. So now I can say, this is e to the limit as x goes to 0 of 1, what was it, 1 over x squared natural log of cosine x. So I could have written this better, but I didn't want to apparently.
So you just want to show the natural log?
Not yet. It's not done with its usefulness. It helped me bring the power down. I don't have to put that e there, by the way. I mean, you just have to remember the answer you get for this cannot possibly be the right answer because it's not the function I started with. If I get 3, the answer is e to the 3rd power. If I get -1, the answer is e to the -1. I've got to raise e to it to kill the ln that I introduced. But why is this better? Can anyone see what's a better way for me to write this thing? Yeah, now that's a ratio. So we kind of did this backwards before. We made it a ratio because I feel like maybe I'm going to use L'Hopital's. What do I check to make sure I can use L'Hopital's? It's a ratio check. Is it indeterminate?
Yeah.
When you plug a 0 in, cosine of 0 is 1, natural log of 1 is 0. And when you plug a 0 in x squared, you get 0. I like it. So it's 0 over 0. Hospital dude says, I got you. Or L'Hopital, to be more considerate. So now I can just apply L'Hopital's rule. About 4 weeks from now, you're going to understand this. Derivatives are awesome. Because we're about to get into like the opposite of differentiation. We're going to undo derivatives. And then you're going to remember, you're going to realize, oh, derivatives kick ass. Because you can always attack something with a derivative. So what do I mean? What's the derivative at the top?
1 over sine.
Nope.
1 over cosine x
Yes.
times sine x.
Natural log of stuff is 1 over stuff times the derivative of stuff.
So that's
Derivative at the bottom is,
tangent. That's just one tangent.
is that still indeterminate?
Yeah.
Yes. But what's the top? What's a better way to write the top now?
Negative tangent.
Yeah, negative tangent x over 2x. And then you can do L'Hopital's rule. Why can't I do L'Hopital's rule? Because it's still indeterminate, it's still a ratio, yes? So as long as it's indeterminate and a ratio, you can apply L'Hopital's rule. So could you apply L'Hopital's rule 5 times in a row? Yeah.
Okay.
Do you hope you don't have to? Yes. Because derivatives kind of build most of the time. You get product rules kind of. One more time. I don't know why I'm doing this whole problem, but oh well, I'm doing it. What's the derivative of tangent? Secant squared. What's the derivative of 2x? Ain't no damn way we're gonna use L'Hopital's now, because it's determinate. Bombs frickin' 2. I don't care what the top is, I can get the answer. And when you plug a 0, and what's secant of 0?
0.
No. 1. So this is negative 1/2. I couldn't stop myself. I wanted to know what the answer was, damn it. So you're all welcome. But, I mean, do you remember doing this type of thing before? When we did derivatives, we had to take a natural log so we could do implicit differentiation. Because if the problem was take the derivative of this, that is not in the form of any rule. It's not a constant to a variable, it's not a variable to a constant. It's a variable to a variable. We do not have a rule for that. We do kind of, I made one, but oh well. To be honest, I'm not sure how it would apply on this one, so I'm not even gonna try to say. Yes?
Wait, so I just wanna say, why'd you put that natural log to begin with?
Basically everything I just said.
Property of natural log.
By the way, I should have made a point out of this. What form is it in to begin with? Cosine of 0 is?
0.
Cosine of 0 is? 1. 1 over 0 squared goes to 1 divided by really small goes to really big. So this is 1 to the infinity. Now, why is that indeterminate? Does this actually get to 1?
No.
It does not get to 1, correct? And does the 1 over x squared get to 0? Or what? Infinity, sorry.
Yeah.
Does it get to infinity?
No.
Hell no. Not a damn thing gets to infinity. You can travel for an infinite number of years and still not get there.
No, and beyond.
Infinite years away.
Buzz Lightyear was wrong.
It's always infinite years away, huh?
Buzz Lightyear is wrong, there's no and beyond, it's just infinite.
Yeah. Or Buzz. But you know. It's more of a mental thing.
110%, coach.
So 1 to the infinity, why is that indeterminate? Because 1 to any power is
1.
But does this ever equal 1? No. 1.0000001 to the 18 billion to the billionth power is humongous. 1.000000001 to the x goes to infinity. 1 to the x goes to 1. This approaches 1. Does it approach 1 fast enough so that the answer is finite? I don't know. That's why we do L'Hopital's rule. See, fast enough. Rate of change. Derivative. That's why L'Hopital's rule makes sense conceptually. What the answer is depends on who's getting there faster. That's what the hell L'Hopital's rule is all about. Yes? Derivatives are how quickly something's changing. Limits depend on who's getting to something quicker. Maybe? Okay, so like,
I don't follow where you did the EDX.
all right, real quick. How is it? B to the x. I can rewrite that as e to the x ln b. I can always do that. Why does that work, Jeff? Where can you
Because
put this x? I'll
the
tell you where to put the
natural-
x. A. Where's the x go?
Up
Back
at the
up,
top.
correct? What did e and ln do?
Cancel each other.
Original freaking thing, yes? So anytime I have something to a power, I can write it as e to the power ln thing. Of course I can, because this would just go back up, the e and the ln would cancel. What do e and ln do to each other? When you put one inside the other one, they kill each other. How did this help me? Now the parts of the problem are free. They have been separated. I can put one under the other one. I can get L'Hopital's rule. The way it was given to me originally, can I do L'Hopital's rule to that number 68 the way it is? It's not a ratio. I can't make that a ratio. There's a whole piece that's stuck. So of course I have to do ln to get that thing down. Then I can move shit around. So I really want this to make sense. If I take an ln and I figure something out about it, and I get 7, the actual answer is e to the 7. Because I have to undo the ln that I did.
But it's back up in the exponent area.
What do you mean?
When you bring the 1 over x squared back up, it's still
No.
up there.
I'm not bringing it back up. I'm figuring out what the answer is to 1 over x squared times ln of cosine x. I'm figuring out what that answer is. But then I have to raise e to it
Yeah.
to get what the actual answer is for the original problem.
Yeah, but when you bring that thing back up to where cosine is and get rid of the natural log and
No.
e to the x, then it's still up there.
Okay. Let's see if I can say this right quick. So this equals this. Those are equal to each other. So if I figure out the limit of this, don't I have to raise e to it to equal that? That's all. So if you find the limit of this and you get 3, the actual answer to the original problem is e to the 3rd. If I figure out this piece and I get a number, the answer is e to it. Yes?
This is basically just a shortcut though, right? We can just work it out like normal with math, multiply both sides by natural log, bring it down, later on, multiply both sides by e to cancel it.
All right, we'll take the ln of both sides, raise both sides, e to the both sides, yeah. Okay, but that's basically, yeah, it's, what I just said is sort of a shortcut to that, yes. Yeah.
So the other one would just take e to the negative 1 half, right?
Say what? Sorry?
For the question we had originally, just take e to the negative 1 half, which I figured out.
Oh, yeah, whatever the limit, did we actually figure out the limit? Yes. Wait, was it this one?
Yeah.
Yes, it was this one. So what's the actual answer then? Yes, so the actual answer to this is e to the negative 1 half. Because that is the answer for the exponent of e, therefore the answer is e to the negative 1 half. Thank you. Okay. And by the way, if you're going very far at all in mathematics, love the shit out of your book when it still has examples in it. You will get to a point in mathematics where it's concept. I remember the first time I had a little book, it was this big and it cost $128, and I thought, I should be able to rip a page out and go to Wendy's and get lunch. God damn it, my kids, I tried it and they're like, what are you doing? Concept problems. I'm like, wait a minute, holy shit, there's no examples. Just concept problems. Good luck. I'm like, shit, so dear God, if you aren't looking at the freaking examples in your book, you don't make a damn bit of sense to me. Holy shit. Love that they're there. If there's not enough examples, there's a really cool Shams study guides. Shams and REA, but I don't think REA is around or not the same thing. Those two got me through grad school, plus study groups, but I think I posted that to the Canvas shop. I gotta double check now, yeah. I posted some example for YouTube places to go and books to get. Yeah. So a lot of, when you hit a new math class, a lot of the trouble is, what am I allowed to do? What's the flexibility in the process? So if you see enough examples, you start to pick up, oh, that's what I'm allowed to do, right? You don't know what you're allowed to do when you hit something new. So you just gotta see enough examples. Oh, I'm allowed to do that. Holy shit, great. You don't know it until you see it. Yeah, so it's really good to watch YouTube videos, get little study guide books. If you see more examples, you see what you're able to do. All right, enough of that. What else we got? Before I bleed any more students. It's gonna say I put a big old ear bandage on that. These problems, these are all the optimization problems here. Let me go ahead, I'll go ahead and give you guys the answer key one. So, same warning as before, if you haven't tried the practice test, do not look at this at all. And I do want to talk really quickly about the thing that Jeff got wrong. I'm averaging about 97 syllable answers. No, it's both of you. Everybody gets 2 sheets, yes. Don't try to give it to anybody else. It's all yours. All yours. I kind of broke up number 7. You can see on the second sheet of paper. I can't explain anything. Really tough. What numbers are? All right, we'll do another example. I'm sure you get 2 distinct things. So let me point out a couple things. First thing is, number 7 is the one that has all those problems out of the book. I just broke them out into 7, 8, 9. You with me? Those are the ones listed in number 7. Okay. Secondly, right here. That should be, what should that be? If you take the derivative of this, what should be here? 24. I love it. So there should be a 2 right there. Here. On the front page, first page. Where's my pen? Just so you know, it's always exciting. When I make a mistake, it's the best thing in the world. So derivative of this should be 24x, right? Which would make the critical number here 2. Everything down here is the same, except my inflection point should be, I think it's 2, -1. And then the picture doesn't really change that much. That should be the inflection point. So it should be concave down all the way through this point, and then it changes to concave up. So it's really not going to change that much because they didn't do a great job right here. So it should remain concave down until it gets to here, and then it becomes concave up. So it doesn't change that much, okay. I shouldn't have tried to squeeze both things into one, obviously, but I did. There should be a 24. That makes this a 2. That makes this a 2. That makes this a 2. That makes the inflection point 2, -1, I believe, when you plug a 2 in. Which on the picture doesn't change too much because I did a horrible job in the first place, but it stays concave down all the way through there. And then it changes inflection right there. 2, -1. That 2's not a intercept. I didn't want to find the x-intercepts. So I said screw them, and I just found some other ones. The other picture you can see is that idea of the minimum happening where the derivative is undefined. Right? The one for the 7th root of the 6th power was this. Yeah. And you know, if the second derivative is easy to get, even though I had some trouble here for whatever reason, it's so much easier to do the second derivative test than it is to make a whole sign diagram and blah, blah, blah. So you can always use the second derivative test, just sometimes it'll be inconclusive. So if the second derivative is positive through a critical number, that must be a minimum. If it's negative through a critical number, it must be maximum because that was concave down. If it's 0, it's inconclusive. You have to do the first derivative test. So that's one place where it kind of sucks. Like, ah, shit, you got to do the first derivative test anyway.
Second derivative test is basically using the sign diagram too, though, right?
Nope, definitely. I didn't use the sign diagram anywhere there. I found the second derivative. I plugged the critical numbers in. If the second derivative is positive, it's a min. If it's negative, it's a max. That's it. Yeah. If it opens down, it's got to be a max. If it opens up, it's got to be a min. So when I plugged a -1 in, I got 6 positive. It opens up. That must be a min there. Oh, somebody was asking about atomic. Oh, here's Greg's. Are you ready? So what if I ask you, okay, I want you to evaluate this. This is kind of a silly example, but what are you going to focus on? You're going to pretend like that ain't there, right? You're just going to focus on the shit is this. If I can figure out what that is, what would I then do to answer the question? E to that. That is what we are doing when we have a problem like this. Screw that problem. Talk about that problem. I have a problem like this, and I want to know what was that problem about? I already forgot. The limit, was that? Yes. Limit as x goes to 0. I want to figure out, I know I can rewrite this as this. How do I know that? Because if that goes back up, these cancel, I'm back to this. So I can always rewrite something to something else. I can rewrite as e to the x, the power ln base. I can always do that. So if I just figure out this limit, just like this thing over, I forgot where I put it. It's gone. Oh, here. Just like this. Figure out that first. If I just figure out the limit of this piece and I get a number, the answer is e to that. Because that's really what it is. That's really the question. I'm just focusing for a minute on that part so I don't have to carry the e around with me. You could carry the e around with you. You could do that. If you want to, just so you don't forget. Then you do all the work up here, and then it's automatically the answer at the end. Yeah. I like it, I like it. Yeah, so all of these, just to really make sure everybody understands, is on there. They're numbered 79, but just because. I had a pizza problem on my pre-calc test this morning. I don't know, I think I need, that's why when he's home about the pizza, I was like, wait a minute. Pizza, apparently I want some pizza. Stop by Delano's. Where do you guys live? If you like cheese, go to Delano's. It's a big slab of cheese. If you don't like cheese, go to Surfer. What?
Philippi's?
What is it? Philippi's? I've had that before.
No,
Oh.
it is really greasy though.
Sometimes I'm in the mood for grease.
It's really greasy. So if you're having it late at night, don't have it. You're gonna have problems.
So, this is my fault. Any other questions about the outcomes? I got us on pizza. So.
No, there's
I know.
a place in Lakeside.
Passions run wild with pizza. I know. No, I'm not even going. The correct answer is no. No pizza. Anyway. Anything else from homework, practice test, the last quiz? I mean, if not, we could, you know, just, if everybody's ready for the test results, head out. If there's questions, classes and over. So.
I got stuck on 64.3 for the second derivative. I don't know what I did wrong.
Oh, here? Second
Yeah.
derivative, okay. Is that how it goes? Yeah.
Yeah.
So first derivative, what am I gonna do?
Quotient rule.
Quotient rule. So I'm gonna do it a little quickly. Top first, so then 2x times bottom minus top times derivative of the bottom all over bottom squared. So then I get 2x cubed minus 2x cubed, you guys see that?
Mm-hmm.
So then I get 8x plus 8x, I get 16x over x squared plus 4. Is that what you got, Sarah?
Yes.
So, okay. So now if I want to do second derivative so I can investigate concavity, what do I use? Quotient. What's going to
Quotient rule
suck
again.
about that? Bottom's a little worse now, right? So every time you do a derivative, things get a little worse. Sorry. Sorry. Alright, so again, top first, and so 16 times the bottom minus the top times the derivative of the bottom. So what's the derivative of the bottom?
2x squared plus 4 times 2x.
Good. Chain rule. All over x squared plus 4 to the
Fourth.
fourth. I love it.
Okay.
You did, Jeff.
Not that far.
Now, let's see. Let's see if you guys. I'm going to factor the top because this problem is the problem we have to do concavity on kind of shit, so don't I have to find critical numbers?
Mm-hmm.
Don't I want to factor? By the way, are there any critical numbers for this being undefined?
No.
Can the bottom ever be 0?
No.
No, the bottom's at least 4. In fact, now it's at least 64. Or not 64, 256, whatever the shit. Okay. So it can't be 0 on the bottom. Okay. So if I factor the top, what can I take out? What number comes out to the top? 16. You see, it's a little messy over here. Can you guys are gonna be, well, screw it, I'm tired. We're gonna do it all at once. How many x squared plus 4 is gonna take out? 1. So what am I left with? An x squared plus 4? minus, I took care of the 16, but I have a 2x times 2 times x,
4x squared.
4x squared, and I took this x squared plus 4 out. Shaboom. All over x squared plus 4 to the 4th. So then, can this ever be 0? That's a silly question. It's always 16, Jeff. What's wrong? Can this ever be 0? So that's the only thing that could possibly give me critical numbers. Because we already said the bottom can't be 0. Is that cool, Sarah? Where do you see where you lost it on the second derivative?
I didn't. It didn't occur to me that I could start taking things out, so I tried to boil it all, and I was like,
Dear God. I don't blame you. I'm with you. But keep in mind, if my eventual hope is to find where it's 0, I'm going to factor it. I might as well just start factoring as soon as I can. Because then I'm not multiplying shit and making things bigger than it was. Yeah.
Couldn't you, on the top second one, couldn't you fix that
What?
technically? No, down. That one.
Yeah. This will be x squared minus 4x squared is negative 3x squared. Plus 4 equals 0, so you get 3x squared equals 4, you get x squared equals 4/3, you get x equals plus or minus rad 2 over rad 3.
Mm-hmm.
Blah, blah, blah. So you get some nice critical numbers, yeah. Maybe not nice. 2 over rad 3. Not the nicest number you ever saw, but, you know. Definitely not the ugliest number you ever saw. So, a little public service announcement. Again, we talked about this before. If you are currently really behind in the homework, first thing, you're not alone. Second thing, stop doing every problem. The test is on Monday, so you have between now and Monday. The most important thing for you to do is to get practice of a wide swath of problems from every section. The absolute worst thing you could do is come to the test and have like whole sections you haven't done anything out of. That does you no good, right? So I don't know if you guys can ever get to the point where you believe me. I'm still gonna say finish this, correct, whatever the shit, right? I'm gonna say that, and you're like, whatever. The most important thing are the tests. They're the heaviest weighted things. Now, the most important thing is understanding shit, but the most important thing to get ready for are tests. Homework helps you get ready. Helps you get ready. So if you don't have time, or you want to devote your time in different ways, then don't do all the homework. I'm still going to hold you accountable. I'm still going to be like, finish this, whatever. You're not going to say, well, Jeff, you told me I didn't have to do it. No. I'm saying, get ready for the thing that counts the most. You guys with me? Please turn. Okay. You always have the Math Science Center. I know a few of you guys go in there. You always have me in my office hours. I understand if you get tired of listening to me, I talk a lot. Right? I bore myself sometimes. Anything else, guys? Quick question. Do you guys have a YouTube channel you go to?
Yeah.
To help or for help? What do you got?
Organic chemistry.
Organic chemistry tutor, that's a big one. I think it's better than Khan Academy. Huh?
Math is power.
Math is power?
Yeah, I think that was it. It's got a blue logo.
I gotta look that up. Math is power. Let's go with that.
I've been doing another one.
It sounds like Captain Planet or something. Who would say?
Yeah.
Math is power.
Math Professor V.
Professor V?
Yeah.
I've heard of Professor Leonard. You guys heard of Professor Leonard?
Mm-hmm.
Math with Professor.
Look up Professor Leonard. He's really good. Because listen, I don't, if I don't make sense, I want you to find something that does. That's all I want. I want things to make sense. And I'm okay. I don't need it to be me to make sense. Professor Leonard, he sets it up. He's in front of a little whiteboard. He's got his whole thing. Kind of goes step by step. It's fantastic. It's great. That's another place to go. He says things in a different way.
Sorry,
Maybe
math is power for you.
Math is power.
The number 4.
Oh. Okay, 4. Jeff. Yes, gotcha. Okay. Professor Leonard, and again, I'm pretty sure I put it up in Canvas, a list of resources. Did you say you saw it up there, anybody?
You took a survey from us.
I did.
You made a list.
And I put it up in 180L, but I can't remember if I put it up in 180.
Think you did.
Although you guys are like logging Canvas is first day. I understand. I don't use Canvas much, but
And Professor, if you don't mind, for the classmates that have joined the Discord, by all means, you know, everybody that's joined the class, we can always meet up together on Saturday or Sunday night or something and do a group session together to help communicate to us, to help each other understand what we're having issues with.
yeah, are some of you guys in the Discord?
Yes.
Okay.
So, I mean, granted, this entire, throughout the entire semester, we can always meet up once or twice, 2 times, 3 times a week, and help each other out to understand something a little bit better.
Yeah, Discord's a great way, especially when you live in disparate places and you're not able to get together somewhere. One time, a student invited me into the Discord. I joined, and they were saying how horrible it was. I was like, oh.
That's a power move.
Well, two people really didn't like me, and I'm like,
Oh,
that's
great.
I'm like, yeah, this guy sounds terrible. By the way, that's me. Awful. So yeah, don't let me in the Discord. You guys can let out whichever you want to. I'm never gonna make a Discord because I feel like that crosses a boundary. But you guys, if you make a Discord, that's awesome. It's just another way to meet without physically meeting. So I think I see David if you want information.
5 minutes away from one another, so.
Yeah, exactly. Yeah. Okay. Yes. What's up? Oh, I know. So I took number 7. Look at number 7, and I blew it up. There's like a bunch of problems with number 7.
Nancy Pie's pretty good too.
Who is it?
Nancy Pie.
Nancy Pie or Fancy Pie?
Nancy. Nancy.
Nancy
P.I.
P.I. I like that. Yeah. But I thought private and this. Who's Pie is? Now I really want pizza. I love it when there's students, you don't have a question, but you just don't want to leave in case somebody asks a really good question. I always love it when I can sense that that's what's happening. I'm like, I got nothing. So now it's the awkward part. That's what just stares.
The bartender says, no faster than light particles in here. Tachyon oxygen bar.
You ever had cilantro and pineapple on your pizza?
What's up?
Ugh.
Cilantro and pineapple.
I've had Hawaiian
That's
pizza.
a great way to make sure I don't eat your pizza.
No. What it is it's actually, it's not very much cilantro, but it's very little. But there's a place next to Mary's Donut Shop in Lakeside.
Oh yeah?
That is a bar and grill place. They got burgers, wings, and they got this one barbecue, kind of like a barbecue wine.
Yeah, what is it? Barbecue.
It's barbecue sauce, but like as far as the red sauce, they use barbecue. And then it's pineapple ham, they add ham to it, if you like it, but it's just a little bit of cilantro. It's really
Okay.
good. Get that and a cold beer.
Just, yeah.
The
It is fun, I promise you. I've talked to a lot of people, a lot of my friends that have never had barbecue Hawaiian pizza. And once they try it, oh my god, they're so good.
There's one at OG's that they have one of their
OG's,
specialty pizzas that's a barbecue chicken one that has onions, cheese.
Oh, yeah. Yeah.
And they do the same thing where they don't use the marinara, they use the barbecue sauce instead. And then they have big, not big chunks, but chunks of chicken on there.
When I first moved here, I lived next to Woodstock Pizza.
Oh, Woodstock, yeah.
I just tried Woodstock pizza,
Are they still there?
friend lives by it.
Yeah, it's still there.
I
Well,
wonder if it's still just as good. It was
well,
pretty
where
It's really good. It is.
are you talking about the Woodstocks up by SDSU?
By SDSU.
Yeah,
When I
yeah,
first
that
moved
one's
here,
still
I
there.
lived right down the road from SDSU.
When did you move here?
2005.
Oh, so
Some of
you.
you guys were not quite born yet, is that true?
Well, what month? What month did you move?
January.
Remember? Oh, then I was 2 months away.
You weren't quite here yet.
I was 2 months away from being here.
I was 2 years.
Oh.
I was 2 years old.
Oh, I was like, you were 2 years away. How the heck are you here?
I took version 4.1 and then we went over it and I realized I messed up and I have to do mine 15 again.
Go for it.
But as far as if you want a
What?
nice.
Wherever you are here. There you are.
Burrito, that's gonna fill you up. Style you.
That only